Good morning. We've zoomed into Redlands, California for day 2 of our plenary session for the 2021 Esri Dev Summit. Today is going to be an amazing day. We're going to talk about ArcGIS with a comprehensive system overview and lots of valuable highlights for you as developers. We're also going to be talking about geospatial AI and spatial analytics. These are going to be the latest in analytics and artificial intelligence capabilities in ArcGIS for you as developers. So let's dive right into it. I'd like to introduce Sud Menon, who's the Director of Software Product Development at Esri, to talk about ArcGIS. Sud?
Good morning. It's great to be here with you today. My talk is an overview of ArcGIS 2021, the system and its underlying platform, including what's new and a bit of what's coming. ArcGIS is a comprehensive geospatial system that supports multiple communities. Our goal is to serve the GIS community, as well as the growing need for mapping and location services, as well as for location analytics. ArcGIS also serves the developer community via its comprehensive APIs and SDKs, and of course, the services and runtimes. Geoenabled Systems deliver independent and focused solutions in areas like urban planning. There are multiple implementation patterns for utilizing ArcGIS, including the desktop pattern, the enterprise data center pattern, the cloud pattern, as well as the embedded pattern, where location-enabled apps are powered by ArcGIS APIs and services. The cloud pattern can be achieved using the ArcGIS SaaS and PaaS offerings, as well as by deploying cloud software. The core of the ArcGIS system consists of products delivered as software, ArcGIS Pro and ArcGIS Enterprise, as SaaS, that's ArcGIS Online, and as PaaS, that's the new ArcGIS Platform together with ArcGIS developers. Both ArcGIS Enterprise and ArcGIS Online include a full complement of apps. Let's walk through each of these components of the ArcGIS system, starting with ArcGIS Pro. ArcGIS Pro is modern professional desktop GIS software that works with all of your local and enterprise data sources. It's also an excellent companion to both ArcGIS Enterprise and ArcGIS Online, and it comes with a full suite of extensions. The latest release of Pro from December has many new and improved features, like you see here, including GPS device support. And its follow-up, which is arriving in just a few weeks, will add even more performance, as well as functional enhancements like support for BIM models in the IFC format. ArcGIS Enterprise is a way to implement comprehensive GIS in your own infrastructure. It runs both on-premises, in your own data centers, as well as in the cloud. It provides all of the core GIS functions and comes with a full set of apps and extensions. The latest release of ArcGIS Enterprise has numerous enhancements, including the ability to schedule notebooks and updated versions of popular apps. The next release of ArcGIS Enterprise will be available in May, and it includes enhancements in the areas of administration and publishing, as well as new authentication options, and lots more. It will also introduce a brand new deployment option, ArcGIS Enterprise on Kubernetes. ArcGIS Enterprise on Kubernetes delivers GIS using cloud-native architecture. It's a new deployment option based on microservices, containers, and Kubernetes. Each independent capability, such as hosted feature services or spatial analysis services, is delivered as its own independently scalable microservice. Its benefits are streamlined installation, dynamic scaling, easy upgrades that minimize downtime, higher resiliency, and easy integration. It will be available in May for Red Hat OpenShift, as well as for Azure AKS and AWS EKS. Later in the year, it will be available for the Google Cloud Platform. ArcGIS Online is the world's largest mapping and spatial data sharing ecosystem. It's growing rapidly, both in terms of the number of users the number of items, and the audiences it serves. It's based on a globally distributed implementation of geospatial services across Azure and AWS, and it offers data hosting options in 3 global regions: the US, the EU, and Asia Pacific. Coming in the next release in April are significant enhancements to collaboration and sharing between partnering organizations. The new map view also comes to the fore, exiting beta, and as well as the new and improved dashboard. ArcGIS Online also has a number of key extensions, including Hub, ArcGIS Velocity, and ArcGIS Image for imagery, remote sensing, and raster GIS. And that's something that we're introducing in 2021. ArcGIS Hub extends ArcGIS Online with collaboration and engagement. It connects organizations to their communities of interest and has many new enhancements for usability and accessibility, for team management and survey integration. It's seen enormous use this past year in the context of the pandemic. ArcGIS Platform enables developers to access the underlying services that power ArcGIS through a true PaaS offering for building mapping and location-based applications. ArcGIS Platform is PaaS with a new developer experience. It's for any developer who wants to add mapping and location to their apps. It allows developers to use their choice of mapping API to access the platform's rich location services and content. It provides you with a new way to authenticate your application with the ArcGIS Platform through industry-standard API keys. All of this is offered through a simplified business model where you pay for service consumption. The same developer experience and technology, as well as the same access to ArcGIS location and geospatial services, also allows any interested developer, including developers working for GIS organizations, as well as partners and ISVs, to build apps that serve the GIS community. This includes full support for authenticating SaaS and software GIS users using OAuth. In this case, the business model is different. The developer produces and delivers the app. Subsequent service consumption is paid for by the consuming customer. ArcGIS Platform provides a rich set of location services that include everything that a developer enabling their application would expect. Base maps, the hosting of data, data visualization services, geocoding and routing, as well as maps and data and spatial analytics. ArcGIS developers provides extensive capabilities, as well as documentation that allows developers to easily find the tools and technologies that they need. ArcGIS includes APIs and SDKs for web and mobile app development, for building add-ins, and for extending ArcGIS, as well as for automation and data science. Developers can also use their choice of open source APIs to work with the services in ArcGIS. ArcGIS also includes low-code app builders for both web and mobile apps. Let's turn next to the foundational capabilities that GIS delivers. We will visit each of these in turn. Smart mapping enables easy and powerful data-driven mapping. The new map viewer has been designed from the ground up to be data type and distribution aware. Recent additions include layer blending, and we are excited about the advent of integrated charting in the April release of ArcGIS Online. Dashboards help communicate the latest information in clear and summarized ways and have reached incredible levels of use and popularity. The latest release of Dashboard is built on the 4x JavaScript API and supports all of the new mapping visualizations. Location analytics is about delivering powerful interactive spatial analysis with a familiar modern BI experience. ArcGIS Insights connects to a wide range of data sources and enables you to easily create linked maps and charts that help you explore and understand your data, as well as share that understanding with others. In the area of field operations, we're excited about the new integrated Field Maps app that supports viewing, data collection, and location tracking in a highly efficient and productive manner. There's also continuous innovation in both Survey 123 and Quick Capture, both of which are very popular. Operational awareness and back-office coordination is achieved using Dashboard and Workforce. Spatial analysis and data science on all types of data, including tabular and feature data sets, as well as raster and network data sets, as well as 3D data sets, is a core capability of GIS. ArcGIS comes with a large set of tools that can be driven via the user interface, as well as via modeling and scripting using model builders, as well as through integrated notebooks built into Pro, Enterprise, and ArcGIS Online. ArcGIS also includes high-performance big data analytic tools implemented in the Spark distributed processing architecture. These tools are available in Pro as well as in Enterprise via the Geoanalytics server. Recent areas of focus in spatial analysis and data science include efficient data engineering tools, as well as the addition of spatially adaptive time series forecasting tools, as well as significant advances in spatial machine learning and spatial statistics, as well as suitability modeling. We have an entire session of today's plenary allocated to spatial analysis and data science to help you see this in more detail. GeoAI, based on machine learning and deep learning, is of great interest. There have been rapid advances in the integration of deep learning into ArcGIS in numerous areas, including for information extraction, from images, from 3D point clouds, or from unstructured text. This includes keeping pace with the rapid advances in deep learning in areas like object detection and semantic segmentation, on RGB as well as multispectral imagery, as well as point clouds and meshes. It has included creating and making available pre-trained models for common tasks like building footprint extraction and land cover classification. These are available for immediate use or with further retraining on your data. ArcGIS is a comprehensive system for imagery and remote sensing, providing a full set of tools and capabilities for imagery management, visualization and exploration, and analysis, as well as for map and data production from imagery. ArcGIS supports managing all types and formats of imagery, including drone, aerial, and satellite imagery, with the ability to manage very large collections of imagery. Visualization and exploitation is available across a range of desktop, web, and mobile tools, including ArcGIS Pro, as well as Excalibur, and it includes the ability to work with full-motion video. Analysis includes both image processing, as well as raster GIS analysis, and now fully incorporates deep learning for information extraction. In the area of mapping from imagery, ArcGIS includes Drone2Map as a self-contained, easy-to-use desktop application, as well as SiteScan as a SaaS-based integrated solution for drone-based mapping of construction, mining, or agricultural sites. Both generate map and data products in native ArcGIS formats. In addition, ArcGIS Pro and Enterprise also include built-in support for orthomapping. Reality capture is an area of great interest at the intersection of imagery and 3D GIS. This is about the ability to create mapping products. These are point clouds, DSMs, true orthos, and textured or integrated meshes, as we call them, through the photogrammetric processing of imagery as well as LiDAR data. Show for ArcGIS is the latest addition to the product family in this area, and it supports processing of very large collections of imagery, including both nadir and oblique imagery. While Drone2Map and SiteScan are focused on project-based workflows, Shore is focused on very large automated data production workflows that are of interest to mapping providers and mapping agencies. I'd like to talk next about ArcGIS Image for ArcGIS Online. This is the new SaaS imagery extension for ArcGIS Online for imagery management, visualization, and raster analytics. It's been available in beta since Q4 of last year and will be released in general availability in Q2. The process of using ArcGIS Image begins with uploading your source imagery to ArcGIS Online for hosting in the cloud. This process supports a comprehensive set of raster types and formats. Imagery may be hosted as tiled imagery layers or as dynamic imagery layers. Both of these can be visualized and analyzed. Tiled imagery layers are stored in a cloud-optimized raster format with full support for all pixel types and depths and multi-band, multispectral imagery. Images can be uploaded and stored as individual layers or as collections that are fully mosaicked as part of publishing. Dynamic imagery layers support primarily large image collections that are managed using mosaic datasets, and these collections can be mosaicked on the fly. In addition to dynamic mosaicing, these dynamic imagery layers also support server-side on-the-fly application of raster functions. Raster analytics can be driven from the web user experience, from Pro, or from Python, and provides a comprehensive set of raster functions. Analysis jobs execute on the server and create new persistent layers. Large areas are analyzed using parallel and distributed processing. Image processing, raster GIS processing, and deep learning are all supported. We're very excited about this. ArcGIS is a complete 3D GIS that allows you to manage, visualize, and analyze 3D data. The 3D GIS information model includes 3D point clouds, textured or integrated meshes, and 3D objects, as well as voxels and BIM. Such 3D data may be stored as database features in BIM files and LAS datasets, but also as web scene layers based on I3S, a tiled and streamable format for fast visualization over the web, which is also an OGC standard. 3D data supports smart mapping and data-driven visualization and can be used in global as well as local scenes. Recent advances include support for materials and physically based rendering, new 3D symbol sets, and the addition of voxel layers to the model, as well as interactive mesh modification tools and the integration with game engines that you heard about and saw yesterday. It's worth taking a moment to discuss the power of combining database-driven 2D and 3D features with these 3D meshes generated by reality capture. These 3D textured meshes, which you can think about as a kind of 3D images, they bring full visual reality and a high level of detail to the table. The features that are overlaid or combined with the mesh, they bring intelligence to the combination, allowing the user to inspect entities of interest and understand all of their applicable properties, such as ownership or zoning, or the number of vacant apartments in a building. Up-to-date information that comes from transactionally updated geodatabases. It's a really great combination. This next slide illustrates what is possible when you make this combination happen. In the center, you see 2D GIS features, polygons, being overlaid or draped on a reality mesh. It is possible to inspect individual polygons to understand zoning or other properties. On the left, you see the use of the latest mesh modification tools in ArcGIS to flatten and then replace a section of an integrated mesh with the results of proposed new construction. This could be represented as either a 3D object layer or a BIM layer. There have also been very significant advances in the area of 3D analysis, including the ability to interactively explore volumetric data. This includes the ability to work with voxel layers using slices, sections, and isosurfaces, including the rendering of voxel data using cumulative transparency and the ability to generate and capture time animations like you see here. There have also been significant advances in interactive tools like line of sight, viewshed, measurement, and slicing tools. Deep learning combined with 3D geoprocessing can be used to detect and extract power lines from point clouds. There are also a number of different tools available to extract 3D buildings from the outputs of photogrammetry. This is an area where much is possible, and also one where the tools continue to advance. The 3D Analyst geoprocessing tools have also advanced in their ability to work with integrated meshes and point clouds. This allows, for example, the use of batch geoprocessing tools to overlay building footprints over a reality mesh and then clip out the individual meshes for each building to the output 3D object or multi-patch feature layer. ArcGIS implements 3D across the system, which means that you're able to visualize and interactively analyze 3D data described across desktop, web, and mobile applications, builders, and APIs, like you see here on the right. RealTime GIS is another area of great interest, involving tracking, monitoring, and alerting of continuously changing data that can represent either moving objects or stationary but changing objects. The latest addition in this area is ArcGIS Velocity, which is a new real-time capability extension for ArcGIS Online, allowing customers to ingest feeds of data from all common IoT and other sources and perform real-time streaming analytics, as well as persistent and recurrent batch analytics using big data tools against the archived data. Data management and editing are at the core of the system of record aspect of GIS. Our efforts here have been in newer industry geodatabase models for utilities, parcel fabrics, hydrologic networks, as well as roads and highways and pipelines. Each of these models is accompanied by editing tools that are appropriate to the model and support the correct capture and editing of information. ArcGIS supports the implementation of geodatabases in all of the leading database systems and platforms running on-premises or in the cloud. Let's turn next to the Geoenabled Systems. These are fully productized offerings that support focused workflows like urban planning. The Geoenabled Systems include ArcGIS Urban, Mission, Business Analyst, Indoors, and GeoPlanner. I'd like to now talk about what's next for Esri Technologies. We're working in numerous areas across the board. In 2021, we'll have multiple releases like we did in 2020. Things we're particularly excited about and that are in active development targeting release in the second half of 2021 include a work to integrate knowledge graphs, link analysis, and graph database into the geospatial information model. The integration of GIS and BIM for project delivery and project management. We're also working on connectivity to cloud-based SQL big data warehouses from Pro, Enterprise, as well as Insights. We are also working on bringing big data analytics to the cloud for your on-demand Spark clusters. In addition, all of these areas that you see here are in active research and development. There's a lot to look forward to.